So the question is about part 4 of the assignment, about the strategy. Um, you want the strategy to determine the order of the tree. Well, a tree structures have an ordering, right? Um, and which ordering you use is going to change the structure of the tree. And so you want that ordering to determine the structure of that tree. But all the trees are always ordered in some fashion, right? Yeah, the order. I mean, you always give an order, right? Maybe implicit um, ordering, but there are lots of ways to order a tree. So you're still not happy.
The strategy is a property of the tree. You keep saying return.
Yeah.
The strategy is not meant to return anything. It's just
Yes.
it's a property of your tree. The strategy is part of your tree.
Yeah.
So if your strategy was just regular order, you just use regular
Yeah.
eagles on that side.
What if you change the strategy? Set new strategy. Well,
Yeah. So I've had that question to come up several times. And what I did when I came up is let's go look at the Java API and look at there, right? They don't have an ordered collection per se, but they do have a priority queue. And priority queues, you have to specify how do you know which has higher priority, right? And so when you look at the priority queue, what do they do? That in the constructor, they say, give the ordering. And then when you look at the methods in the priority queue, they say they don't give you a method to change it, right? So that's one possibility, right? You just say, look, when you create the thing, you specify the ordering, and then you're done. I mean, now if you want to allow ordering to change in the middle, right, you have to redo the whole entire tree. And then the question is, do you want to just return a new tree and leave the old tree as it is, or do you want to reconstruct the whole tree? And the question is, how often do you want to change your mind in the middle of a tree that changes to complete order? In the priority queue example, they give you a way of getting the array of elements out, right? So then you can stuff those elements in another tree with a different ordering, which is definitely sort of a clean way to implement it. You don't have to worry about us internally redoing the whole structure. It's like, okay, no, I give you the ability to do it if you want by giving you, give me all the elements in a collection, and then I'll add that collection to a new tree, empty tree with a different ordering.
So for some of these patterns that are opening up data hiding,
right,
exposing things, or exposing using methods like visit this, visit that, does it make sense to have like an inner or nested class that acts as a proxy, and then so that instead of having to like have your main class a visitor or open up a bunch of access or method, say for strategy pattern, you have like an inner class that's the context that sort of just is a proxy that forwards to private methods, and then you can pass that to something like a strategy something that needs to be like an accept instead of having to have that as public.
I'm not quite sure how that solves the problem.
Because there's no public interface to those methods that you'd rather hide. The only way that someone can get access to them is if you pass them. If it's a private inner proxy class, you pass them. So that the only people who can access those or even see can even be aware of them. I mean, that's complexity.
Well, in Java, we can use the various access levels, right? There's public and package and private, so we can make things in a package, right? Access, and then classes that we want have access to those methods we put in the same package, right? So there's.
So you recommend using that.
It doesn't add the same complexity, right? It achieves some of the same.
Yeah.
And part of it is, how far do you want to go to, lock down your internal structures? Using a package level access signals the programmers that, okay, this is not for general consumption, but we can. In the C++ world, that's what friends are for, right?
I try to avoid package is new to me, because it's not kind of the classic level, Java. Nice.
Yeah. I mean, yeah, I mean, right? I mean, but in friends, you basically get access to everything, right?
That's
Whereas, but in the package level, you still have private, and they can't access that. Well, so the question is, basically, how do we make our packages, right? Where do we put into a package? And there's sort of two aspects to it, right? A package, what things go together, right? And what a package is, okay, is util package, okay, it's all the utility, or it's java.lang, so it's all the basic language structures, right? So it's all these things which a package sort of, there's some sort of concept, right? And so what is that concept that we're talking about? And then the other one is what things have to go together, right? And so the visitor, okay, we don't want to expose everything to make it public, so we can use package level. And we also have to look at, when we look at the visitor pattern, right? The structure is only tied to that visitor interface, right? But the visitors are tightly coupled to the things they're going to visit, right? So in that case, it sort of makes sense to put the visitor in the same package because they're tightly related to the things they're going to visit.
I'm just kind of new to packages, but I mean, would it be reasonable to have the homework assignment in the same package? I didn't know. If I had the whole homework assignment not using a package.
No, I normally don't look at that, but
Okay.
Other questions?
Are you anticipating another?
Perhaps, but there's time is short. Yeah, including today, we've got 6 class meetings left.
One of those we get
Yes, which leaves 5, right? And then usually the last one is the review for the final, right? So now we're on to 4.
times.
So in data part mentioned traverse said the elements of what should be done.
So the question is about who decides the traversal and the visitor pattern, right? And there's 3 basic options, right? One is the structure determines it. The other one, the visitor determines it. And another one is you have an iterator that determines it, right? Um, and the trade-offs are, if the structure does it, it's usually easier. But then that provides you with only one way of doing it, right? If the visitor does it, then different visitors can traverse in different ways, and there might be reasons for that, right? In search trees, there's depth first and post, pre and post order, and all those. So if you want to support multiple different ways of traversing through the structure, then you really want the visitor to do it. But of course, to do that, right, for the visitor in the binary search tree to actually do the traversal, it needs access to left and right, right?
In this like the one who has access.
Yeah, the problem becomes when we're dealing with assignments, right? We don't have a real context to evaluate what's going on. Um, so the discussion I just had is that's what I would go through to decide in this particular case, do we want to do it in the structure or during the visitor, right? Um, and then you look at the context and you decide, well, do I foresee an issue where I want to have the different traversals? And the answer is yes, then I would go with putting the visitor, even though that makes the visitor have to deal more with internal structures of the structure, right? If the answer is no, then I would probably do it in the structure.
And if there's no context in one way or the other.
Yeah, flip a coin. Yeah, I mean that's. Again, usually I don't like to say I'll do it this way because then as soon as I do that, everyone does it that way, and then this question doesn't come up, right? Um, it's always a nice out.
Using the iterator last kind of hard.
Yeah, it's not impossible, but I mean it's just you really has to keep a stack and strings.
But um,
And what's the difference? Well, again, if one of the things I do in these cases, I look at, for a Java, I go to the Java API and look what they do, right? So you go into array list, and what do they do? Well, they've got an add method, which adds one thing, right? And then they've got a add collection method, which does, you pass in a collection, right? And of course, you know that how the method's implemented, right? It's like, it's just a for loop, or just, just,
Because add my collection, the same add function more than add all
right?
or has certain.
Well, if you have an add collection, you have an add method, right? So why not make it public, right? I mean, you already have it. If you have an add method, it's 2 lines to add a add collection method, right?
Do you expect it to string?
Okay, I mean, it's,
I'm not sure in Java it's supposed to, that if that's like the standard that you're supposed to do that or need it or
well, toString in Java is used in the debugger, and so I find it useful to do it. Just I'm not ever going to use it because otherwise in the debugger you get this object with the hex code number after it, right, or whatever. And if we do toString, then I get something that helps me out. Yeah, so the equals and the hash, um, there are default implementations, which in general work well enough. Sometimes it's not a big deal. It's just that the toString, you're not going to be using hash functions on your tree or node, right? So it's there and you don't need it. Tostring, you might find useful when you're debugging, when you're,
doing the standard for that one. Just basically,
yeah,
and then, I mean, if I'm doing
yeah.
plus sign,
Now, in Java, when you got an array list, um, say array list is a string, what do I add to my array list? When I say add, array list dot add, what argument do I put in? And what type is it?
over time you set your array list.
And when I pull an element out, what do I get?
Again, you get whatever you use.
So if I have a binary search tree that's going to contain strings, what type of elements do I add to the tree? String. Do I add a node containing a string? What? Right, but that's how you store the tree is the internal data structure, right, to a tree. And do you want clients to have to know what that structure is? Not really, right? What's even worse is if they have to create the node to put it in the tree, that means they have reference to the node, which means they can now do something with it.
That brings up that for this binary tree, it kind of makes sense to make it generic. Once I did that, one of the things with the null path is to use a singleton and have one instance. As soon as you make a tree generic in Java, basically.
Right, because
I guess I'll erasure that to object C++.
yeah, it's type systems, the tighter you want to make them, the more of these little edge cases you run into. And so the Python people and the Ruby people and the Smalltalk people would say then that's the price you pay for having all this type stuff.
It's weird though, because in Java, unlike C++, it seems like your templates don't really need a template parameter. You can always kind of just use them with object and you get a warning. You should really. I tried to even work around it by doing a whole bunch of casts. The problem with that is you're only going to get one instance. So you can you can create a null object for a string,
right?
But then later when you go create a null object for integer, it's going to overwrite that because you want static.
Yeah, and C++ and Java treat their generics completely differently, right? C++, it's going to generate a new class for every type you want to pass in, whereas Java only creates one class for the generic.
Java's kind
Right. So any other questions? Well, I have my hopes that it's soon.
should we expect those before this one? I'm concerned being that we make the same.
That's my goal.
Are we paper on this one, or are we using
Paper. Now, I must admit, I did make a mistake on the third assignment. I should have had you implement two different visitors. So you really should either actually implement two different types of visitors or pretend you do, because if you only got one visitor, it's easy to optimize the visitor pattern out of the picture, which you don't want to do, particularly since the assignment is to show you how to implement the pattern, right?
I used a second visitor to test.
Yeah, right. Yeah. So we're getting towards the end of the gang of four patterns. So last time I talked about the visitor pattern, which in about 2 weeks you'll have a good understanding of, right? Prototype, it's a much simpler pattern to understand. So it's a creational pattern, and the basic idea is you create a prototype object of the type you populate the fields with what you think should be there, right? And then when you want a new object, instead of creating a new object, you just clone that current one. Right? That's it. And that's what That's what that's what it says, right? A little fancier terms. It's like basically you create a single object, configure it the way you want, and then after that you just make a copy of it. And they give various. When you might want to do the pattern. And so, of course, at some point, these patterns become so, when do we want to use it? And so the prototype patterns are used in the insurance world. And, basically, insurance salesmen, they have various types, you got life insurance, home insurance, car insurance, right? And then it's like, okay, well, here's your basic package, but now do you want higher liability, lower liability, right? Do you have a lot of stuff in your house? You want, more coverage, less coverage on that? Do you have do you have a lot of computer equipment? Do you have a lot of, and so you're just adjusting from a base, a standard package, right? And so the prototype can be used there as well. You create a prototype for each different standard package, and then that object you modify, but making changes appropriate for that customer. And they actually, right, you can make a copy of it, right? And then that's a prototype pattern, or you can basically just throw the differences, right? Create a decorator that says, okay, no, we change this to that, we change this to that, change that to this, right? In the wrong way. And of course, then we run into the issue of in the prototype pattern, we make a copy, you have to worry about copying everything, not just shadow copying. Because otherwise, unless of course those things are immutable, right? Then we can do a shadow copy. Yeah. So it's just how deep you go, and if we follow the current trends to make things immutable, then we don't need to go. And there's actually been languages which are prototype based. That perhaps the most famous for this in the general public, general computing public, at least known, is Self. Self was a project that was done at Sun, and the goal was can we make a dynamically typed language as fast as C? And the answer was yes, we can. And to make sure that no one thought we were cheating, it was highly dynamic, so it was prototype based. To create an object, you basically create a prototype object, and then every time that you just cloned it. JavaScript initially was prototype based. There's that prototype, right? And you can change the prototype of the object, and so it's a very simple pattern, right? It's just basically create an object, and then every time after that you just clone it.
So how is that typically organized? The book doesn't go beyond, okay,
you copy it.
Type and you copy it. I mean, is that normally organized in an abstract factory or something similar? I mean, how do you organize all these prototypes and just make sense in object?
Well, one way is to create a static method in the class to return a copy. Yeah.
But is it one of the
multiple
for one class? Because in games they'll use it because you might bad guy.
Right.
And then but you want to have the guy you and the guy you to the boss and all that indexing.
Yeah. So then you have a static method with an argument, right? Yeah. And then I know there's just copy it, right? I mean, at some point, some of these patterns become like, well, you guys got to write a paper on this and write a book on this. I mean, but again, that's part of the benefit of the patterns movement is people are able to publish things which in some circles are obvious and in circles weren't. And most people who publish are academics, and they only publish because it has to be something new and different. And this made it acceptable to publish things which are already known and make it.
For prototype-based languages, it's a little bit different. How do you actually add types to your
That depends on which language you're talking about. So JavaScript is a weird.
You can add new.
Yeah, and you do it itself too. You create an object, and then you can clone it, and then you can add a method just to that object.
How is it different?
How's it different from a template method? Well, the template method really doesn't specify how you create the object, right?
What it does.
Well, we should say not template method, but the factory method. So the template method doesn't necessarily create objects. So to me, the difference is the prototype versus the factory method, right? And the factory method, just a template method, returns a new instance of an object. But the factory method pattern doesn't explicitly state how the factory method creates the object. It could just say new foo, right? Or it could clone a prototype and return it. So now we're down to the patterns that I always leave to the last for various reasons, depending on which pattern it is. The flyweight pattern, in part because I don't think it's a pattern that's used very much. And the goal of the pattern is, look, when you have a large number of really small objects, right, there's a lot of overhead there. And so can we reduce the overhead by extracting some information from the object? So to motivate, I use an example of text. For example, these days we don't have ASCII characters. I mean, we got documents, we have text, right? And text has a font and a font size, and all its information. And so, if we're going to represent a document and use objects for each character, it has all the information of what type of font it is, right? And with the font itself, the font size, the color, right? Whether it's italic version or the bold version, that becomes a lot of information to store per character. And so, in this case, right, why store all the information per character? Why not just store somewhere else and have a pointer to that information? Right, in a particular document, you may only use 2 or 3 fonts, and so you only need 2 or 3 font objects, and you have pointers, right? And we'll see later examples of that. Java does this weird thing with strings, which does cause confusion among beginning programmers. Right, so okay, cat and cat, rat, cat. I mean, and then yeah, so A1 is not equal to A2 plus rat, right? But I can now say A3 is equal to A2 plus cat intern. And now A1 and A3 are the same. And I can then say A4 equals cat plus rat, and it's the same as A1. And in strings, what does equals equals mean in Java? Yeah. They point to the same object, right? Um, and so, yeah, this intern, right, does this weird thing about it's sort of the canonical version for each string. And then we can use pointer comparison rather than character by character comparison. And so someone asked what intrinsic versus extrinsic state before the exam. This is where it comes up. Um, so it's intrinsic state and extrinsic state. Um, intrinsic is the one that is basically independent of the actual object. It's basically all of them have it, right? If all of them have it, then we can extract the information out and store it somewhere else and have pointers to it. And the extrinsic state depends upon the actual object. And so we can't, if we pull it out, we don't save any space because only one of them has it, right? So you only get, and so the goal of the flyweight is to say, look, what we want to do is, if I have all these objects to save space, I want to look at the data inside and say, what data can I store separately, right? So all the intrinsic state I can store in one place and have pointers to it and save space. Right. Of course, then the complication becomes then when you want to deal with the object, right? All the industry state is somewhere else, and then we need a mechanism to grab it, right? Bind it back together when we need it. Right. Hard part is figuring out what we can pull out, right? So here's a simple example, right? Run arrays. I have this string. It's much more efficient to basically, when a run of the same characters, just say character and then how many times that character appears, right? If they're common, if there are runs, right? Right. So here we only need to store 3 characters and 3 integers, right? Well, and we've got 26 characters up there. And so, Smalltalk actually implements a run array that they use internally when they've got various things like this. Really, just you basically compress it down into a much smaller space. So then we can use this idea in text, right? Look, so if I got that text, right, I can use this run array to store the font information. Because typically, you're not changing font or sizes or types all the time, right? usually there's paragraphs of the same type of font, same size. It's just basically a run array would be a good way to store that type of information efficiently. So now if you go back and you read, I think it's chapter 2 of the book where it talks about the example. One of the examples they talk about is implementing an object-oriented text editor, right, running with objects. And so there, right, if you're representing that text as objects, then you'll want to use the flyweight for the characters, right, because you want to pull out intrinsic state to save space.
Any insight as to why flyweight condition?
All this, but there's two different meanings of flyweight. Yeah, flyweight one is just the thing you put in the pole, but the other meaning is lightweight. And so the flyweight pattern is just basically when you get I mean, you need a large number of these objects to for this to make sense, right? Because there's only 5 of them, you're not going to save much space, and so it's not worth the effort, right? Um, so how many times have you come across we have a large number of small number of objects?
In direct instancing, basically, like if you have like 1,000 trees, instead of giving it 1,000 models, 1,000, you give it one tree model. Say I want 1,000. You give it a big array of extrinsic state, basically, and then it'll call the shader pipeline for every instance of that tree with the parameters that you give it. You can rotate it, size it, increase the number of trees, make per tree. I mean, that would be the
Yeah, perhaps I need to know more about the example, but the idea is the same, right?
Yeah, your intrinsic state are
all
the polygons.
Right.
Tree. It's kind of like the font example.
Yeah.
State is
And so this pattern, right, one reason I prefer it to last is because it seems like a very specialized pattern to me. The facade is another one of these specialized patterns, in part because it deals with size. And why is it? Hello. Interesting. I distinctly remember modifying this last night. So F-22 is an old fighter jet. I don't know if it's still in service, but It had 1.7 million lines of code estimated on it. It seems like a lot, right? 787 has 6.5. Looks like it's spelling too, so I must have two copies of this. Okay, the Chevy Volt, that's the embedded code. That is, you've got cars now have got little processors all over the place. That is the code in those little processors. It doesn't talk about the entertainment section or the navigation section. 10 million lines of code. The radio navigation system Mercedes-Benz is about 20 million lines of source code. Mac OS, the old version, has like 86 million lines. This one is hard. I had a reference a number of years ago that said you have 100 million lines of code. This is someone who had worked with Mercedes-Benz. I came across yesterday a reference that said current cars have about 100 million lines of code in them. Yeah, Debian 5 has like 350 million lines of source code. And Tesla's got a version of Linux running in it. So Tesla cars have that plus a lot more. Dealing with all this code becomes challenges. And it's the same person told me about Mercedes-Benz. He said, yeah, I mean, it's periodically in Germany, the cars will just need to be rebooted. So you just pull off the side of the road and reboot the car and take off again. There's also this slightly terrifying example of at one point in Thailand, some diplomat was in a Mercedes-Benz car and the car just froze and wouldn't do anything. Couldn't roll down the windows, couldn't open the doors, and you had bulletproof glass. And this is think of India, right? How long can you stay in a car in India during the day? No air conditioning, windows up. Before you die, right? They eventually had to get some of the sledgehammer and just beat the glass in. The electronics just wouldn't work. Right, so most of the patterns we talked about don't deal with large things, right? Oh yeah, the pattern textbook contains over 8,000 lines. So the facade pattern is, well, you have the system and it gets complicated. And so instead of having the rest of the program to deal with that complication, you create a sort of a facade class or a class that acts as an interface to that subsystem, and the rest of the program just deals with that facade. So the way I like to think of the facade pattern is it's just objects scaled up, right? In a class, what do? We have a certain amount of operations and data, and okay, then we want to just forget about all that and hide it from the outside world, so we put it in a class and make things private. And then here's the public interface, right? And so we can then forget about how does the priority queue work in a In Java, we don't know. You just it tells you the behavior you're going to get, and then we would add and remove, and that's it, right? And we don't have to worry about, is it a display tree, or is it a binary tree, or is it a B tree, or is it stored in an array, and then they do the funny indexing. No, we just don't care, right? We don't know. And so for me, this is the same thing. It's just like, okay, we built this, it's a car, and we have this radio thing, and our navigation system is complicated, and we'll put a facade on it, and the rest of the software in the car doesn't have to worry about it. We just talk to that facade or that interface, and life becomes simpler, right? So it's sort of like the same thing, and except with scaled up. It's like, okay, instead of having 10 fields and 35 methods, we have 35 classes that are involved in the subsystem. So, same idea, right? Well, it's too complicated to put things all in one pot, so we create small little pots, and now we got too many small little pots. We create a bigger pot to put those pots in, right? Now we can deal with just a big pot. Um, right, so it's just basically, like I said, we want to, and then they go on a lot about should we allow the client facade to actually interact directly with the subsystem or not? Um, but that's the same issue we have with objects, right? In Java, some things are public and some things are private and some things are protected, right? And generally, we want some public and the rest private, but like we saw earlier today, right? There might be reasons to make things package level access to allow some clients to interact with a wider interface to the object. So we have the same problem with the facade.
Yeah, it was kind of, to me, like the real value of facade is information hiding.
Right. Right.
A nice
Yep.
API object
Yep.
on top of it.
Exactly.
They almost seem to present facade as like an easy alternative interface. You don't want to get into the guts, but I kind of shouldn't. You really want a facade to be effective, because if you allow other systems to access their classes, even the whole, I mean, if your facade is closed, then you can change whatever you want.
Right.
And
Yeah, so I would say that's the goal, right? Like the visitor pattern, maybe we should make the visitor pattern have special access to certain parts of the structure, right? So it becomes harder, I think, at a larger scale to say we can't do this, everything has to be only facade. It's also hard to talk about it because it's hard to get that level of experience.
there's definitely, you definitely want large package
Nice.
with facade. You definitely want something exposed.
Yeah. I mean,
Fancy.
yeah, right. So they talk about, I mean, I don't think so, but, and of course, languages don't really scale up this level, right? They don't give us, I mean, we got packages in Java. Um, I guess.
So that's why I forget what lecture was, but we were going over the command queues.
Right.
That scales up pretty well. And that's
Right.
a good way for subsystems. It's
Right.
another, maybe it's an alternative to the facade, but it's a way for subsystems to talk to each
Each other.
without having
Right. Yeah, and that seems to be more, I mean, a current trend. But one example I know of the side pattern is, so Smalltalk is sort of weird, and well, it's weird in many ways. Um, but one way is it's basically it's written. The whole thing is written in Smalltalk, except for a very small number of primitive methods that are implemented in the virtual machine. So the entire windowing system is written in Smalltalk, and when you get Smalltalk, you get that source code with it. Um, and the compiler is written in Smalltalk, so um, and that the compiler is always loaded into your IDE, and so you have access to it. And it has 75 classes, so compiling is complicated, right? I mean, the parser and there's create tokens, and if you take a compiler class, you recognize that compilers are complicated, and they give you a compiler class, and you basically just say compiler evaluate, and you give it an expression, and it does it. And there's some other methods. So I can actually I'm defining the string. I'm defining a method called reset. You give it a comment, and then reset the count. And it's all a string. And Smalltalk uses a single quotes of strings, so I don't know why. And then I'm just basically, in my compiler, I can just say parse that method in this class. Done. Right? And so literally, you just have to, if you know about the compiler class of Facade, you can use that whole mechanism, and it's doing all the standard, parsing and tokenizing and affect syntax tree and evaluation for you. And you don't have to know anything about all the other stuff. It's like just evaluate or compile it into this class. Which, in aside, does mean you can write code which, at runtime, takes in a string and compiles it and as a method and adds it to a class and executes it, which is something you don't want to do very often. I don't know if it's a good example. Objective-C, they call class clusters. So like number, right? They have all the standard types as classes. I mean, int and long int and short int and right. Um, but they don't expose that to the programmer. There's just number. And then when you basically instantiate a number class, you give it a value argument, and then that will then select the right instance of it. Um, and so the reason I like to leave this one to the end is because it's not something most people have much experience with, including me. When you have enough software, you have to deal with a large piece of software to make subsystems.
A lot of times, though, I mean, I think I've dealt with Facade.
Right.
Made them.
Right. Yeah. Yeah.
One problem we have with the application, data reader class in C#. It's obviously a Facade. So when there's like bad sequence in there, like that.
Right.
By the time you get to the call stack of all the subclasses and sub, I
Right.
think would be a simple
Operation, yeah.
method. Yeah.
Yeah.
So we have to keep increasing the size of the buffer for the string with every version.
Right. Bigger, yeah. Yeah, so it's and I think that's all that, oh no, well I almost said there's a reason not to use it, it's just that what's the largest piece of software you've dealt with? Yeah, I mean it's not easy, right? Because
We didn't do mediator.
yeah, what happened to mediator? Well, next time.
We got all the patterns.
I thought it. Oh no, it's coming up. I'm not sure why it just got in between or not. This is just a break from patterns. Log meter, just another attempt to try and come up with a principle that helps you write better code. And this was done a study. People studied a bunch of software, and they determined that software that follow this principle is easier to read, easier to understand. And so basically, complicated way to say, well, in method M of an object O can only call methods of the following type. You can call all. So methods of all, if you're an all, then you can call it methods of an object. Arguments of the method, that makes sense. Any object you create in that method you can interact with. Any fields of all, right? You can, if they objects themselves, you can talk to those objects. And global variables.
What else would it have access to?
Yeah, that's my first reaction when I read this. Like, oh, what did you just? I mean, what's the restriction here, right? Another way to specify it is you only get to use one dot, right? Okay, I can do that, right? That's okay. This becomes okay. Well, yeah, but if I'm doing it this way, it's not okay. Why? Because A is either a field in my object or a parameter or something I created, but B, what's B? It's not an argument. It's not something I created. It's not something, right? And now the reason for this is when you're trying to understand what's going on, what's B, right? Don't know. Right. Yeah. Well, but how do you get well, if we're in Java, um, how do we get those helper methods? Um, things like this, right? Again, we don't, what does method B return? We don't know, right? Though I would say this is better than this in the sense that at least we know what it is, right? I've come across a number of examples of this, like, okay, what am I doing? I don't know. What is this, right? So then I separate a list and then try to figure out what that is so I can actually then know what's going on. And yeah, and then what about this, right?
Yeah, but that's okay if they're all messages to the same object.
Yeah, right. So this is just, right?
The goal is to limit the number of objects
Objects.
you have to think about, or the number of classes you have to think about when you're editing.
And hidden ones, right? It's not clear what that is, right?
But even in your last example, when you set it to food, it still increases the number of classes that you would have to learn about.
Right. Yeah. But at least I know what it is, right? Whereas here, yeah, it's all sending the message the same thing. And actually, Smalltalk has special syntax just to do this: send a bunch of messages to the same object. So you don't just make explicit what's going on. Because here we only know this because we know what the builder is doing, right? And so we know, okay, the builders all return the same thing. Whereas in Smalltalk, the syntax says, no, here's the object, and here are the 5 methods, and it's always going to that same original object, as opposed to having to know by convention that these dots are all sent to the same thing. So basically, it's just a simplified version of this, right? And yeah, okay, I guess I don't. I guess what? Somehow I must have grabbed the wrong copy of this lecture notes because I thought I had the meteor pattern. And I thought I had that size table done. We'll good stopping point here.
I had a quick question. Because for some reason, I was thinking about that when I was doing the homework, and all my methods start with if something equals null. I remember like 10 years ago, there was a big movement for contract-based programming, where you'd say, okay, this method can't accept null, this method won't return null. I mean, is that still a thing? Or
It's still a thing. It's a good way to think about your objects. Okay, what does this method do? What inputs will accept, will not accept? And so one way we see that now with language like Swift has guards. So the first thing you do is in your method, you say, okay, here are the conditions that I'm not going to take care of, and I go throw an exception or return null or something to just to
what do you say it's called?
guard.
Oh, guards?
Yeah.
Okay. Because I think that was the thing that we to have language support for, right?
Yeah.
Instead of just as a comment. You know?
Yeah, and so IFL did that, right? So in IFL, you would basically specify preconditions and postconditions for every method, right? And that was then the compiler could do some checking for you and also document it. Like this is what
And you can do runtime check.
you could do runtime checks and you could turn them off or on depending upon if you're really worried about performance, you could turn them off. And
But that's still a thing that you think about. It's not a dead topic.
it's not a dead topic, but languages outside of IFL, I don't know of any language that really took that to heart. I mean, it's